Okay, so we need to solve this or do this word problem, okay? Smoke jumpers are in free fall from the time they jump out of a plane until they open their parachutes. The function h of t equals negative 16t squared plus 1600 models a jumper's height in feet as a function of time at t seconds for a jump for 1600 feet. How long is a jumper in free fall if the parachute opens at 1000 feet? Okay. So we want to know the time. We're going to solve for t for time. Okay. But it tells us we want to know at 1000 feet. So that means h of t is equal to 1000. And we say find the time. That's what it's asking us here. So we're going to use our equation. That's given us right here. But we're going to plug in 1000 in for h of t and then solve it. So I'm going to get 1000 equals negative 16t squared plus 1600. Okay, so back on Friday, when we solved a quadratic by square rooting, we want to get that squared variable by itself. Okay, so Mason, how do I get rid of the 1600?
Subtract it.
Very good. It's being added, so I use the inverse operation and subtract it. That's going to give me negative 600 equals negative 16t squared. I still want to get the t squared by itself. Tarek, how do I get rid of the negative 16 then? Very good. It's being multiplied, so the inverse of multiplication is division. So I divide by negative 16. So I'm going to now divide 600, negative 600 divided by negative 16. And that's going to give me 37.5 equals t squared. Does anyone remember how do I get rid of a squared variable? Very good. The inverse of squaring something is to square root it. So if I square root on one side, I have to square root on the other. And I'm going to get the t equals and I get 6.12. What would my other answer be? Negative, right? Remember on Friday we talked about this. There's a positive answer. There also has to be a negative answer because I don't know which one it is. However, we also need to have this make sense within the problem we're dealing with. Okay, does it ever take you negative seconds to do something? Can I take negative 6.12 seconds to do a problem? No. Okay, so in this case, we really don't need that negative because it doesn't apply to what we're talking about. We're talking about time, and time's not going to be negative. Okay, so this is 6.12 seconds to fall 1,000 feet. Any questions over that? Okay. Okay. The bell's about to ring. We'll come back and finish this. So we're going to find that. We're going to graph it. We're going to solve this by graphing. You could solve this algebraically, but we're not going to do that today. We'll do that on next week sometime. So let's graph this. So that top one is a quadratic. So we need to find the vertex. Can someone raise their hand and tell me what the vertex is? Mm-hmm. Very good. -4, -3. So we're going to graph that. I'm going to go where x is -4 and y is -3, which is right here. Then we need to remember our a value. A value is the number right here. Since there's nothing there, it's 1. Does anyone remember the pattern rate of change? What's our pattern rate of change here? Yep. Very good. That's a over 1, 3a over 1, and 5a over 1. So from this, we're going to go up 1 and over 1. Up 1 and over 1. Then up 1, 2, 3 and over 1. Up 3 and over 1. Then up 5, 1, 2, 3, 4, 5 and over 1. Up 1, 2, 3, 4, 5 and over 1. Okay, you want to try and graph your parabola as accurately as you can. Because you do want to see where they intersect. Any questions over that? Okay, the next one is a linear equation. So you have to remember back to last year when you graphed a line, and it was y equals mx plus b. So you need your slope and your y-intercept. So the y-intercept, does anyone know the y-intercept of that equation? Okay, y-intercept. Where is it going to cross the y-axis, you guys? At 3. Okay. And our slope is the number in front of the x, which is 1 over 1. And remember, slope is rise over run. Is this ringing a bell for you guys? So we're going to go where y is 3, which is right here. Then we're going to go up 1 and over 1, up 1 and over 1. Then we're going to go down 1, left 1, down 1, left 1, and keep doing that so we have a very accurate line. So here is my line. And we want to identify where the line and the parabola intersect. So this point is at -5 for x and -2 for y. And then at -2 for x and 1 for y. So that is where f of x equals h of x, where the two graphs intersect. Okay. Let's review that. Where does f of x equal h of x? Just to review where they intersect. Any questions? Okay, next one. Okay, a student solved the following quadratic below. Show the work they did to solve. Who is correct? What was the mistake that was made to get the incorrect answer? Okay, so you guys look at those in your pairs. See if you can come up with the mistakes that were made and how you can fix those mistakes.